Hi, this is Jing-Chen, and this is my third milestone video. It's with my omnidirectional robot. For this milestone, I have upgraded the software to allow it to do some pathfinding, and I'm almost to the level of letting it map its surroundings. But just for now, just a quick demo of what it can do right now. So, this robot is right now being directed by its software to explore a 5x5 area around it. It's going to do this using a series of steps. First, it's going to find its own coordinates. Then it's going to find a set of target coordinates. Then it's going to attempt to find a path from its own coordinates to its target coordinates. And by doing this step by step by step by step, it will eventually explore the entire grid. Now, there's many problems with this. One is that it requires a large amount of memory. And two is that because I have no sensors in the robot, this action is actually very inaccurate because the robot does not know where it is. It's just really, really roughly estimating its own position. And this is causing the robot to become very, very far and collide with the imaginary grid that it's trying to map. Now, these are some problems that I'll go into detail later, but for now, yeah. So, the program that's on this robot is basically is a search algorithm that's nested in another search algorithm. Now, this is pretty hard to come up with. It was certainly really hard to debug. I don't think I could have written this in Arduino without first the help of another piece of code that I wrote, which is a Java simulation of my robot's actions. Now, this piece of code, in this GUI, the red square is the imaginary robot. And this code, when run, shows the steps of the robot, which is it finds the nearest green point, which is the frontier, or the exploration zone, and it then proceeds to scan the areas around the explored area, and therefore expand its known area of points. By doing this step by step, it will eventually cover the entire grid with actually gray points, which is points that I have visited and I know that this is a safe point to travel to. This is the starting point for the code in the Arduino. In fact, the code in the Arduino is almost directly copied from the code written in Java with some modifications that account for the robot actually having to move instead of just teleporting us in this program. Now, some problems I encountered when writing this code were that the Arduino ran out of memory due to the fact that I had too many lists running because I had to run many search algorithms in this program. So I had to switch from my old Arduino Uno to an Arduino Mega, which has 4 times as much memory and could easily handle all the lists and custom objects that I created for this program. I also ran into the problem where the robot did not align to the grid very well. It skewed. I mentioned that earlier. I'm planning to fix this by adding encoders, which allow the robot to measure how far each individual wheel has turned, and by adding those up, it would be able to gain a better estimate of its position relative to its last position. Now, some other improvements I've added on this robot are soldering all the electrical components to a perf board and screwing that perf board into the wood, so it's no longer a breadboard and it's no longer flopping all over the place and taking up a large amount of space. I also finally got around to adding a power switch, which has been a really big help, so I do not need to wrestle with my robot to gain control of it when it starts losing control. And I switched to a Mega, obviously, and I have cut out wooden slots in my robot for locations where the encoders will be installed in the future. Well, that's it for this time. Thanks for watching.